and welcome to Chapter 4, Basic Probability. Now, probability and statistics are two slightly different animals, and generally they're lumped together, probability and statistics. What we're going to look at today are the fundamental or the foundational levels of probability, which will help us gain an understanding for what we're going to do in the future with statistics. There will be quite a few vocab words and some formulas and some basic principles. We will not use the computer in this chapter, so you can take a break from PhStat. I want to congratulate most of you on a job well done on your tests. At this point, you should all be finished, and I want to congratulate you and hope that went okay. I want to make a couple comments on your homework up to this point. A lot of the homework I see is it's cluttered with a lot of information, and I know what I'm looking for so I can find it. But think about if I was your boss and I didn't know what I was looking for. The correct answer, or the good answer, or the answer that's going to get you that promotion gets lost in a clutter of information and unnecessary information that I don't need. Thinking back to 342 and 343, especially, they asked you a question: what is the relationship between the Wonderlic score in the graduation rates for college football players? Now, the Wonderlic score is an intelligence test, and it wants to know, as your intelligence test scores are higher, what happens to graduation rates? Well, we would expect, as intelligence goes up, graduation rates to go up. We'd expect that relationship to happen. So we'd expect a relationship like this. Okay? Now, the question is, what is that relationship? And that question was C, 343, C, similar to 342, C, ask a very specific question, and that is the heart of what we're trying to get at. It asks the covariance and the correlation, yes, and you should be able to match the correlation of this picture. It wasn't so strong. The relationship looked like this. You should be able to match that relationship with the relationship in the book, and the book lists 6 different relationships and strengths, and this, I think, ended up being positive 0.6. Now, I made several comments that you need to be able to draw from this, that as the Wonderlic score goes up, graduation rates are going up. So we're looking at all that data, but we're boiling it down to the fact that as Wonderlic scores go up, graduation rates go up. So if you were the coach and you wanted good graduation rates, you should recruit in players with high Wonderlic scores. Also looking at the coach's salary in the coach's salary in the revenue for the teams. We would expect a higher salary for the coach the more the revenue for the teams, and that was in 342. Okay? Now, that's in the past. We're going to tuck all that information away, and we're going to move forward, and we're going to have a test now from chapters 4 to chapter 6, and we're going to have 2 tests in the very first 6 chapters to get a good foundational grip of what's happening in statistics. Then from chapter 6 until whenever, we're going to pick up what we can do in the time we have available, and we're going to take this basic 6 fundamental chapters and apply them in inferential statistics down the road after chapter 6. Okay? So, chapter 4. Final note, the homework that was presented in PowerPoint was perfect. Absolutely perfect. It was really great to see. If you think about making your homework a PowerPoint presentation for me or for your boss, not for me. If you submit it to me, I know what you're looking for, but submit it to your boss or to your wife or to your husband or your boyfriend. someone who doesn't know what you're looking for. And think about your questions and giving a report. What does the Wonderlic score say about graduation rates? Well, you see here that there's a slight positive correlation in Wonderlic score in graduation rates, and so therefore, and draw your conclusion. Next slide, next problem, next slide, next problem. It's a very nice way to present homework. And a couple of students have been doing that, and it's absolutely beautiful. So I would encourage more of that. Okay, chapter 4, probability. I'm starting on page 148. Now, probability is denoted as piece of x. You'll see piece of x or piece of whatever. This means probability of x. Probability of x occurring. Okay? This word is inferred, usually dropped. Piece of x. The probability of x occurring. Of it actually happening. What is the probability that x happens? Okay? The probability of an occurrence is given on page 149. Yeah, 149, and the piece of x is given as x over the total. Now, x is the number of ways an event can happen over total. Okay, number of ways an event can happen over the total number of possible outcomes. Okay, for instance, if I flip a coin, a head and a tail, and I'm looking at the probability of a head. Now, what are my possible outcomes? I have two possible outcomes. I have either a head or a tail. And I'm looking at the number of ways that a head can happen. How many ways can it happen? I would flip it once. A head can happen only one way. Only one way a head can happen out of two total possibilities. 1/2. My probability is 1/2. That's very simple, rudimentary kind of probability. Okay? Now, if you move that forward into a die, and just to draw a basic die up here, I know my angles are wrong, but if you have a 1, a 3, and a 4, so this is what I'm talking about. It's 6-sided. It has 6 sides, and the sides are 1, 2, 3, 4, 5, and 6. 6-sided, sides 1, 2, 3, 4, 5, and 6. Now, if I'm looking at the probability of an odd, probability of an odd-sided row on one row, excuse me, probability of an odd side coming up. Now, total number of ways that can happen. Well, that could be a 1, that could be a 2, that could be a 3, or that could be a 5. A 1, a 3, a 5. Out of how many? So that's total is 3 ways. Out of how many? 6. Again, the probability of an odd is 1/2, or 3/6. Now, okay? Now, this is what we describe as a simple event. A simple event, and I'm just going to read. Okay, I won't write these on the board. You can read with me. I'm on page 150. A simple event is characterized by a single characteristic, an odd, a head, a tail, probability of red on a roulette wheel instead of black. Okay, a joint event is when you have 2 or more characteristics. For instance, now I have a coin and a dice. So I'm looking for the probability of a head and the probability of a 3. Okay? I roll and I flip. So I want the probability of a head which is 1/2, and a 3, which is 1/6. So now I have a joint probability. I have two occurrences that I want. And how are we going to measure that? Well, what we would do, and we can multiply. Okay? The probability of this happening is 1/12. Okay? 1/12. And why is it 1/12? Well, think about the possible events that can happen. I can have a head and a 1, a head and a 2, yeah, go ahead, head and a 3, head